Hey, welcome back. We're back into our ballistic trajectory worksheet that we built up. Example, I'll put a link to it in case you missed the original video. And we're improving it, or continuing to improve it, by adding different scriptable advanced inputs so that we can explore different variety, but lay them out in a way that's very meaningful and accessible to whoever's using the worksheet. And we've already gone down that path a little bit, so as we skim down, we get the solution to the problem. Again, I'll put the link down if you didn't see the original video. And then we added our slider control, which allows us to control the number of buttons on this. Of course, you can set that to anything you want. Then we added a scriptable text box, which now is taking its formatting depending on whether we come close to hitting our target or not. And so what is it? So we're at 20 points. So let's just, if our target was 20 meters away, in this case, it would be deemed a hit because we set our tolerance to 1 meter. So that was all working. And so we want to carry on that path. And what I want to do is I want to use the list box to give some choice as to the gravitational constant that you're using, or the gravitational acceleration. And we're going to do that by using the list box to give some choice as to where, as far as planetary bodies go, you're doing this calculation for. So let's jump right in. We'll do that. We'll script it up. We'll get it working. And then we'll go on to the next improvement in the next video shortly thereafter. So I'm just going to make some space. So we're going down. We've assumed that the horizontal acceleration is equal to 0. We've broken our initial velocity into components. And now, rather than going ahead and setting up our functions and calculating, let's get some space in here, and we're going to define our gravitational constant based on location. So what we need to do is we need to consider location. Just line that up with everything else, keep it nice and neat. And now we're going to need to give it input our list box. And so it's up here, input, output, advanced list box, and it comes in right like that. And we'll play around with its formatting and everything later on. So I'm going to do this in 2 steps. I'm going to set up the box with its various choices, and then I'm going to do the code that's actually going to assign the value for the gravitational acceleration depending on what that choice is. So let's get into it. We right click, we choose edit. I'll try to remember in post to zoom in on this box so you can read this a little better. Hopefully you're not trying to watch this on your phone. And at the top we see here, this is where Mathcad allows you to script it and choose what's there. So we're going to choose Earth as our first one, which we will also set as default. And then we're going to have the moon. And for number 3, let's choose Mars. Everybody wants to go to Mars these days. And finally, I'm just going to add a 4th one. So I'll do that by copying this and pasting it in. And we'll do Venus. Okay, and then this is now with version 11, this is here by default, list box current selection is equal to 0. So it's saying choose the first one and you could change that to any one of them, but we're happy with that. And I'm just going to add a comment so we understand what we're doing, which is basically current selection is 0 or Earth by default. So we understand what we're doing. And if I haven't made a spelling mistake, I should be able to apply that, close it, and we're seeing here that the list box is now populated. We can size it up to something more meaningful. Now, the only thing left to do is to go in and get it based on that choice to assign a value to the gravitational constant. So we're going to make this equal to G, right? And of course, G up until now, you see it green down here, has been the built-in gravitational constant, which Mathcad recognizes. But as soon as we define it before then, it will default to whatever value it is defined as. So we're going to be good there. So, okay, we've got our list box, and let's go edit it one more time. And depending on how many syntax errors I make when I type it up, maybe the last time for this video. So now we're down into the execute section down here. And so I need to make myself a little bit of space. Make some space here. Outputs, values, that's not what we're using, but I'm going to carry that down here. And we'll fix that later. So let's set it up. So to do this, what we're going to use is the switch or case condition. Fairly easy to set up. And the first thing we want to do is set up a variable which we're going to use. It's going to be the script from the position in the list box that you choose. And so let's do that. List box, get text, and then the current selection. Make sure you get the right amount of parentheses so that we can not have a syntax error. And then I'm going to do a variable for the acceleration. And I'll just start off setting it to 0. And now we're all ready to set up our case or our switch. So we start with switch, and it'll be based on the text. And we open that up. And now we have 4 cases. We need 1 case for each of Earth, Moon, Mars, and Venus. And so we get case where it is equal to Earth. And so as I'm typing this in, like I say, I've said before, I'm not really a coding person. I tend to do a little bit of trial and error and look at some examples. The help is within Mathcad isn't too bad. I'm working in JScript here with the inclusion of Python. I'm going to probably switch over, start doing that a little bit. But it's really just an exploration for me to figure out how to get my syntax right in that, because I haven't been formally trained in this. So it's more accessible than I thought it would be when I first started looking at the scripting. So we've got the first case set up here. So Earth gives you an acceleration 9.81. That's meters per second squared, but we'll add the units once we're back in Mathcad. Sorry, let me pick this up. And I'm going to copy that down. Four times. And get rid of some of the space in here. And at the end of the last one, we need one of those. So now let's update these to Moon, Mars, and Venus, and change the values for acceleration. And I've done some really poor research in that I just looked it up on the internet, but it's good for our purposes here. Hopefully they're right values. And so this is what I found with about 30 seconds worth of effort. Obviously, if I was actually doing this in a meaningful way, I would choose a better source than just Google to get that. And then we have to change our output. So we want output 0 instead of the current selection. What we're looking for is our acceleration. And I think if we haven't made any typing mistakes, maybe we've done it. And we seem to be okay. Let's look. And so it seems happy. Let's get a value for G. And just test this out. We're getting 9.81, we're getting 1.65. Okay, that looks good. So let's improve this. Instead of redefine G, and let's do it G multiplied by its units, which is meters per second squared. And now that error we had is going way down here because it was a units incompatibility. So that's good. We're back in business. And as we change this, we're getting new values and new calculations based on what we did. So I'm going to zoom out on the sheet here so I can look at my outputs at the same time as my inputs a little bit more. So if we're up here and we choose Earth, and I'm not changing the initial conditions at all, getting 20.8 on the moon, of course, we're seeing it goes much, much further because of the lower acceleration. Mars coming in at 53.62 and Venus even less. So that seems to be working. I think we have a decent list box. So in the next one, I'm going to challenge this. Let's, rather than considering air resistance equal to 0, I'm going to make some simplifying assumptions to make it manageable and being able to demonstrate it fairly easily. We're going to look at some horizontal deceleration due to atmospheric drag, which is interesting because, of course, Earth, Moon, Mars, and Venus all have very different atmospheric densities. So that might be interesting, or at least I hope you think so. So we have a list box in the simplest form, basically a single input, bringing back a single variable being returned based on the selection, and then that variable then being used in the calculations. So it's probably one of the most common ways you may choose to use a list box, although the combo box would do quite well in this case too. So if that was useful to you, that's great. Come on back for the next one, and we'll extend this to do a bit of calculation around air resistance. Have a great day.